Good afternoon. Welcome to course Thermodynamics of Materials. Today we are into lecture 111 and 112. So before I start, I have to actually beg apologies for some video deficiency or video trouble in the last lecture. Some four small places we didn't have actually video pictures available. Audio was there. So today what I have located those four spots in the last class. So that I will make up today first. In the very beginning, I'll do that. That will be about, I tell you what, this is about okay, this one and this one, these two, and also some previous formulating equations, the governing equations. There are 2 or 3 lines, so only 4 small things, that I will do. For example, here I have to make a this didn't come out, this didn't actually was not in the picture, in the figure. Audio was there. So without wasting time, first I will make up for the loss, make up for the deficit last day's class, and then I will pick up. These 2 are over. These 2 are over. HSC. These 2 are over. Okay. These 2 are over. I'll take up this last one. After these are over, the how to find epsilon BC, that is ternary interaction coefficient. That I will take actually for today's topic. After I finish this, okay, rediscussion. Thank you. So with this, let me actually finish this. Okay. Plus remove this. There is no point. Just remove this. Because of actually the screen, this whiteboard and the video, actually this didn't cover the entire, okay, the entire space here. Okay. So at some areas the video actually could not take photos. So that's why, but I'll make up today. No problem. Most cases, most part it is okay, but only one I'll do this. Topic is then first the makeup. For making up, just this rediscussion, rediscussion rediscussion of four small points affected by video unavailability. Video unavailability video unavailability in the last class. In the last class, namely lecture 110, 109, 110. This is this initial. Okay, let us quickly. I will not give much time on this because these are all discussed once. For the ternary system, ABC, for the ternary system ABC, we have to put we have to put we have to put xt is 0 in equations 1, 2 and 4. In equations 1, 2 and 4. What is this quickly? ln gamma b is ln gamma b 0 plus epsilon bb xb minus half xb square plus epsilon cc, it will be minus half xc square plus epsilon bc minus xc minus xb xc. That's it. This was there. Okay, minus. Okay, xc minus xb xc. Call this equation. This equation was called 5. Okay, 5. Then ln gamma a. Ln gamma a is what? Minus half epsilon bb xb square minus half epsilon cc xc square minus half epsilon, sorry, epsilon. Okay, nice. Okay, it's okay. It's good. There is no d. D is okay. These three two terms minus. Oh no, there is another term will be there. Minus half EBC epsilon BC XP XC. This call this equation 6. Call this equation 6. And then I said ln gamma c, for ln gamma c, I said try yourself. But I give the answers today. Today I add this. This is I am adding without adding any equations. Okay, I don't want to upset the equation number. So just I am giving the answer. ln gamma c is ln gamma c 0 plus EBB minus half xb square plus epsilon cc xc minus half xc square okay, these three plus epsilon bc is actually cb xb minus xp xc. This is the answer. This actually I am not giving any number, equation number. It should have been given. Since last day I didn't give any number, so I don't want to upset these numbers. Okay, I want to retain these numbers because that will be referred to. So these 2, 5, 6 But this, let me check whether it is correct. ln gamma c is ln gamma c0 EBB etc. ECC xn plus EBC XB minus XB XC is fine. Then next is actually next. Let us take up third. Third is what? This is second. This is third. For the binary now. For the binary system. For the binary system AB. So what you will do? We have to put XC is 0, XD is 0 in equations 1 and 4. That will do in equations 1 and 4. So what is the answer? ln gamma b is ln gamma b0 plus epsilon bb xb minus half xb square. Okay, this. And then for the binary system, we have to put xc0. In equation 1 and 4, I have given this in equation 1 and 4. And ln gamma A is what? What? Minus half epsilon bb xb square. And we give the number of the equations here 5, 6. Then it was 7, and it was 8. Right, exactly. This part was not clear. Some video was actually not available there, so we could not see this part. The audio was there, so this I have rewritten. Maybe here also. Oh, by the way, it's okay. It's okay. So 5, 6, 7, 8, and I have added today. This one I have added. So I have not given any number to this. So this is the first part. Second part is what? This is about the first part. Okay. Second part is about what? Okay. About this gamma b0. Gamma b0. So yeah, I am giving the reference A gamma b0. A gamma b0. What is case 2? Case 2. Case 2. When Henry's law is not obeyed. When Henry's law is not obeyed, figure 2. Figure 2, actually, I have to draw this figure. Then I am drawing this figure here. Okay. This part was, even so, here, figure 2. There are certain lines are here. Certain lines are there. Then after some time you will get this. Even so, in this case also, gamma b0 is obtained as gamma b0 is obtained as del, or rather DAB maybe, since it's binary, DAB by DXB at XB is 0. XB0, which is mathematically established as follows, as established below. So below, then there are some lines, these are already there, okay. The figure 2 actually the problem. So for this purpose, let me remove this part. This is all over. This is our figure 2. Just I am redrawing the figure 2 today. There was some trouble with the, this is figure 2. How will you plot this? XB plotted here, 0, 0 to 1. 0 is A, 1 means B, and here activity of B. Here also 0 to 1. Okay, and we call this point as origin as O. This is the O point. And as before, we had this is the Raoult's law line. Raoult's law line. Now, since actually recall this, I should not explain today that it is actually when Henry's law is not obeyed. That means there is no linear path. There is no linear path. How it was like this. There's only continuously it actually it curves. It undergoes a curve or nonlinear behavior. Nonlinear. So how to get this? We have said this here. Mathematically established as okay. Yeah. This you take the slope. So what is the answer? So let me draw this. I take the slope at the origin. It was nice. Suddenly I made a mistake. Very nice. Okay, also in this. Here, how to get this? Let us take a slope at the origin. It's okay. So take the slope here. Take the slope here. This is what? This part was not. This part was not hard. Okay, in the video. So it was not seen in the video. Okay, in the presentation. Okay, but it was hard. So I write what I said was hard clearly, but it was not visible. So I'm writing Henry's law is important. Henry's law not exhibited, not exhibited. It- Henry's law not exhibited. Why? Because there is no linear part. This is non-linear from very beginning. Okay, so not exhibited, not exhibited. No linear behavior, no linear behavior, no linear behavior, even in the dilute region, even in the dilute region. Acha, in the dilute region. Okay. These small points, one already over. This I have removed this one. This is the second. This part, this missing part. Even so, etc. etc. Second, and this is the third. This is third, and okay, even in the dilute regime, the slope taken at the slope. This is the slope. Okay, this is the slope. This slope taken at the origin, at the origin, and at the origin, which is that is at a O. That is at O. What does it mean? XB is 0. XB is 0 of the origin of this curve. Which curve? AB versus XB means this one. Means this one. AB versus XB. This curve. This is the slope and this is the Raoult's law of the AB XB curve. Of AB XB curve. What is that? What is that? The slope. What is that? Del AB or rather DAB over DXB at XB is 0. Slope taking the tangent and the slope taken at XB is 0. So xb is 0. This is by definition, this is actually is known as, this is the epsilon b b self interaction coefficient. So only this part was missing. Last class, this part was missing. This part was, I tell you, this part was missing, and even so, this part is missing. Here, and the equations that I wrote, okay, and I have removed them, okay, and I wrote minutes ago the equations number. So those some of the equations or some parts of the equations they are missing. That is 1. This is 2. This is a 3. Fourth, I am telling you. Fourth case. Okay, this is over. This part is over. It's EBP. Okay. Fourth is, you consider this. You start after this. B. This is the fourth case. 4 points. Fourth point. Fourth point that has actually have video unavailability. Video unavailability. So this actually, this fourth point is what? This let me. That is the figure 3b that I will draw here. This actually I name this. This again xb goes from 0 to 1. Call it A, call it B, and AB likewise 1, and again 0 here. 0 here. Okay, this is this. And I told you this. This is the one that was actually this point, and suppose there are 3 data points. 3 data points was given in figure 1, 2, 3. These 3 points coming from, this is figure 4b. Figure 4b. To note that figure 4b was derived from figure 4a. So there are 3 data points in figure 4a, and these are the corresponding points. Okay, and this is actually nothing but, this is clear. I am very sorry, this is not activity B. I am very sorry. This is gamma B, derived plot. Activity B versus XP is the figure 4a, and this is gamma B versus XP, the derived values. Okay, so this is there's a 3 points. Okay, so what is this? Then again you draw take a tangent here. Tangent here. This tangent is the slope. Slope is what? Del ln gamma B by del, as you see, del xb, and xb is 0, is by definition is known as epsilon bb. This is how experimentally self interaction coefficient epsilon bb is measured. Okay, so again here actually maybe little clumsy, but I think I can make up this. Yes. Take the tangent, take the slope, maybe take the tangent here, draw the tangent at the origin. No, this is not doing well. the slope, okay, at the origin. So, okay, so what is this? So then let us continue here. Let's explain this. Slope, this is slope I have written, this should be correct. This is just right here. Slope of the tangent to the tangent slope of the tangent to the gamma b xp curve at this separate this curve at xb is 0. So this is clear. This is the slope of the tangent to the gamma b versus xb curve at xb is 0 means here because this is required here at xb is 0 then that will be del ln gamma b over del xb at xb is 0 which is by definition is epsilon bb self interaction coefficient of b, okay, in the solution. Note, draw lines here. Note, since we are focusing here, so remove all this. This is over. This is over. At xb is 0. At xb is 0. Okay, figure 4b. So what you have to write here? Note. Note. Figure 3b. This was missing. This was missing in the last video. Okay, figure 3b last class is derived from figure 3a using how to get this point. Oh, I forgot to write. What is this point. This is actually this. Oh, this is remember this is ln gamma b. This is ln gamma b. Is ln gamma b? See here, ln gamma b. So it is ln gamma b, and this must be ln gamma b 0. Ln gamma b 0. This one. Because ln gamma b at xb is 0 is ln gamma b 0. So this was obtained from figure 4a. So this is derived from figure using what? Using gamma b 0 is del ab by del xb at xb is 0 and gamma B is AB by XB, AB by XB for the other XB values, for the other XB values. Sorry, this is means these three values using this relation and this value using this relation, referring to figure 4a, which I have already shown yesterday, and so you can now connect them. Okay, these parts were missing in the last class. The videos was not available, so this actually I have made up today, so there is no problem. Okay, just only you have to connect this video and the earlier video so that you have no difficulty. But anyway, job is over. These two over. Now I will take up today's topic is epsilon BC, the ternary interaction coefficient. Finding how to measure experimentally, how to find experimentally. Okay, so I am removing this. So this discussion, these are all over. 4 small points that were these were affected by the video and this board placement, relative placement was not appropriate, was not perfect. So we lost some part, and today I have made up. Thank you. So start today's job. Today's job is what? Today's job start is this. See, I call it. This is A, B, C. This must be C. This must be C. C. Epsilon B C. Oh, so hang on. After I have to start a new pen. Yes, it will not take much time. This one, C, epsilon BC. Now start. Let us see. This is known as ternary. Sorry for delay. Ternary interaction coefficient. ternary interaction coefficient. So this is by definition epsilon Bc is del ln gamma b by del xc at xc is 0, xb is 0, obtained from the Maclaurin series expansion that I said. These terms will come, and this is given as epsilon Bc. As I told you, this is effect of C on B. Effect of C on B. How? Effect of Xc, mole fraction or concentration of C on B means on gamma B in the form of ln gamma B. This is X is 0. This is obtained from the Maclaurin series expansion. Okay, what? Okay, series expansion. Applicable to ternary system, ternary why? C, B and A of course is there, solvent. So ternary system A, B, C, where A is the solvent and B is the A solvent and B, C are solutes. BC solutes. So first method, how to find epsilon Bc at a given temperature experimentally. This is the topic. First method, we will find the value of epsilon Bc consistent with the above definition with the help of series of curves. With the help of a series of curves. Series of experimental curves. Series of experimental curves. Curves as shown below. As shown below. Okay. Start. ln gamma b is plotted against xc. This xc is 0 here. ln gamma b. Okay. Suppose this is the curve. This is the curve. Should have. Oh no. I'm sorry. This is the curve. This is the curve. Okay. This is for what? Value xb is xb1 fixed. Fixed. xp is xp1 fixed. When xb is xp1 fixed, we are plotting gamma b against xc. With this xb value, particular value, we are plotting gamma b versus xc, and this xc is 0. So these are the things. And suppose there are 3 points, some experimental points, just the thing. Then what is this? What is this? Then you take a tangent here. Tangent at the x is 0. Then what is this? What it will be? This tangent will be this tangent slope. Slope is what? This slope. It is better I draw dotted. Better I draw dotted. That will make sense. The slope. Achha, I will correct this. Slope is del ln gamma b, del ln gamma b by del xc at what location? Xc is 0 and xb is what? Xb1. So these data points are taken with xb1 and different xc and find gamma b. This then this, okay? And then take a tangent here, okay? It's fine now. Take a tangent and at x is 0. Achha, let us go. I'll come back to this. Next one. xb is xb2 fixed. Again, you get a curve here, okay? Maybe better. Yes, curve here, and take a tangent here, and you plot here xc like before 0, and this is ln gamma b. So what is the solution made of ABC? Ternary solution applies to ternary solution. Yes, I have written here. So, and you are measuring gamma b for this value of xb fixed and with different value of xc, and then once the curve is drawn, then you take a tangent at the origin, which is x is 0. Then you will have what this? This is again the slope. Slope is, tell me like the last time. Slope is del ln gamma b over del x c for which values xc is 0 but xb is xb2 here it's okay. It's okay. This is wrong thing. This is a tangent. So next, this is what this call this figure 4a. Figure 4a. This is figure 4b. Figure 4b. Figure 4c. We draw here figure 4c. Similarly, figure 4c. We are plotting x is this side, x-axis. 0 is here, and you are plotting here ln gamma b. Gamma B is to be measured experimentally. As I told you from activity and mole fraction lesson you can get. So it's an experimental curve. So somewhere gamma B is to measure maybe with the help of activity. And activity measurements I have already told number of ways. Anyway, this is 3 points again as before, 3 points, and again draw a tangent here. This is the slope. Slope is, tell me, like this, del ln gamma B by del xc at xc is 0, xb is xb2, xb3. So I have not written here. xb is, for this curve, xb is xb3 fixed. Last is xb, another four data point I want for satisfactory result. ln gamma b as before, and xc on the x-axis as before, it is 0 here, and this is actually 1. So you draw a tangent here. So x is 0. This is again slope. This is for xc. xb is xb4 fixed. 3 data point, maybe more. 3 I have shown. 3 data point. These are actually obtained for this xb value and the corresponding xc value, and the remaining is xa, and get the gamma b. So what is this? Slope is del ln gamma b over del xc at xc is 0, xb is xb4 constant. So they call this figure as 4b, 4c, figure 4, figure 4d, and draw the final figure. Okay, I'll draw where I'll draw. Where I'll draw the final figure. This is easy. This is I draw here. I draw here. This I want to retain because I will follow this. Our aim is to find epsilon BC with the help of this 4. As I told you, series of curves. It can be more than 4, 5, 6. Actually, greater the number, greater will be the accuracy. Okay, but there is a limit. So when you have 4, 5 data, then it is maybe satisfactory. We consider.
I'll draw here. I'll draw here the figure 5. I hope I will be able to, but I want to remove this one. Okay, only this is required. So remove this. Only this is required. And these figures are required. Because with the help of these 4 figures, I will draw the final figure giving this parameter, interaction parameter, ternary interaction parameter. So this figure 5. This is the climax, the final. What I am doing, follow this. Take a look. I am plotting this gentleman, del ln gamma b by del xc. Okay. I need some space actually here. Del ln gamma b del xc at what it is this? At what I have done here? Xc, all are xc is 0. Xc is 0. Xc is 0. Xc is 0. Xc is 0 and xb is varying. xb1, xb2, xb3, xb4. So I call it xb is xb. This is plotted on the y-axis. On the y-axis. Okay, sorry. This is plotted on the y-axis. And the x-axis, what I am plotting, I want to get xb is 0. There are xb. Then I will generate a curve. Okay, I generate a curve. Suppose this is the curve. Again, I will have 4 points. 1, 2, 3, 4. 3, 4 points corresponding to this is what? xb1. This is xb2. Time remaining 1 hour more. Okay. So 50 minutes over. 1 hour. Okay. Third is this is xb2. Third is xb3 and fourth is xb4 and this is xb axis represented this way. Let me remove this. Remove this. So it will be more clear now. Okay. So only I need this and these 4 figures. These 4 figures and this relation that gives us epsilon BC. So what I am plotting del this one at xc is 0 and xb is xb. But I have to go to xb is 0. How shall I? These are 4 points that I have already obtained. 1, 2, 3, 4. 1, 2, 3, 4. xb1, xb2, xb3, xb4. xb1, xb2, xb3, xb4. Next, just draw this actually smooth extension to the xb is 0. Complete this curve. Okay, just complete this curve. Okay, gradually you actually extend to this xb is 0 value. So smooth extension to 0 value. Once done, then what you will do? Draw a last moment.
draw a tangent draw a tangent is now clear, and this is the curve. Smooth extension of the curve. You may have actually closer data point to xb is 0, closer, that is possible. Then extension a little bit, very negligible extension is required, very small extension is required. So closer to this, supposing these 4 are enough, then we can extend to the xb is 0, and then draw a tangent at xb is 0. If you do this, then this tangent will be what? What? Tell me. Del, write this. Slope. The slope of the tangent, the slope taken at xb is 0, that is the slope of the tangent drawn at xb is 0. Same slope is del ln gamma b by del xc at what value? This is for xc is 0 obviously, and xb is actually now taken to 0. So xc is 0, xp is 0, and if it is so, then the slope is nothing but, by definition, the interaction coefficient, the ternary interaction coefficient. So this is our job. So this is over. This is the first method I told you. Okay. Now I will actually give you a second method. Second method, you remove this. Second method of finding this epsilon BC. Not only that, more than that. The epsilon BC, gamma B0, epsilon BB, all three or more than three. Okay, simultaneously. Let us see what is that method. That method I call it second method. That is the first method I told you, perhaps. This is the first method I told you. This is the second method. I wrote somewhere first method. This was the first method. Second method. The second method has been proposed by okay, my name, myself, Dinabandhu Ghosh, Dinabandhu Ghosh, reference already given. What is that? Already given. Metallurgical material and material transaction B 2010 volume 41B, page 1274, 1283. Consider this. Let us discuss this. Consider the equation. So the equation previously given, previously given for the quaternary system, quaternary system A, B, C, D, and which is given by consider the what is that equation? Recall last class equation one, and actually see if you have for our continuity, I am reproducing equation one. Ln gamma B quaternary system. Recall ln gamma B 0. Next term is epsilon B B x B minus half x B square plus epsilon C C is a self minus half x square plus epsilon D D minus half x D square. Then comes epsilon B C x C minus x C minus x B x C plus epsilon D D nothing but x D minus x B x D, and the last is epsilon C D is minus x C x D. Just let me check. This is equation one. You may check back. You will get this. Okay. Let me check quickly if it is correct. Okay. It is correct actually. I hope it is correct. Half x square y plus minus half x square plus ABC. Is okay. This is correct. Now there are seven unknowns, namely what there are seven unknowns here in equation one. In equation one, namely what are we are going to interaction coefficients we are going to measure. But this time actually we will measure several, not only one. So it's like this. This gives only one epsilon BC. Similarly, you have to try. So many curves are required. So many experimental data required. Let us see what is the advantage here. So there are seven unknowns here. What are they? Let us see. One, gamma B 0, activity coefficient. Epsilon BB, self interaction coefficient of B. Epsilon CC, self interaction coefficient of C. Epsilon DD, epsilon BC, this ternary interaction coefficient. Okay, BC, effect of C on gamma B, and epsilon BD, epsilon CD. 1, 2, 3, 4, 5, 6, 7. 7 unknown. Acha. Namely, let us write them out. Gamma B0, epsilon BB, epsilon CC, epsilon CD. Then what you write? Then epsilon CD. Okay, I am very sorry. Epsilon DD rather. DD. Then DD. Then epsilon BC. Then epsilon BD. Then epsilon and epsilon CD. So 1, 2, 3, 4, 5, 6, 7. So 7. Namely this. So 7 equations are needed. So 7 equations, 7 equations are needed to solve the 7 unknowns simultaneously. 7 unknowns simultaneously. This is possible if 7 activity coefficients gamma b, which are the gamma b, follow this, 7 gamma b needed, and for the known composition, for the compositions, okay, we will measure the equilibrium compositions for the, which is easy, for the known composition, then you will set up 7 equations, 7 gamma b and 7 compositions, including xb, xc, xd. 7 equations, 7 unknown. You will be able to solve. And simultaneously, what you will get? 7 parameters. Here it was only one parameter. 7, 3 cell, 3 ternary, and activity coefficient at 0 concentration, gamma b 0. So this is at 7 activity coefficient gamma b. But how often? Interesting. This can be obtained very often. There is an advantage here. Often obtained from the solubility data. Solubility data. Often obtained from the solubility data are known if these 7 activity coefficients are known as a function of composition. Since as composition changes, gamma changes, those 7 different values will emerge for 7 different compositions. And compositions are given by xb, xc, xd, and our balance is xa. So we don't mention that automatically. Are known at different compositions, at different compositions, implying which are xb, xc, xd. These give compositions. At different compositions of the system with dilute or concentrated solutes. Dilute or concentrated solutes. Okay. So why? But this is the advantage. Concentrated solutes you can use because there is no restriction about this. See, when you measure this interaction coefficient here, like here or these 4 figures, there you will try to make dilute solution and get the values, and then that extrapolated to 0. When it is dilute means it is close to 0, and then you say several dilutes and then you extrapolate to 0. For the measurement is required, but once it is measured, then they can apply to any concentration. This is free. You may argue that if the concentrations are high concentration, then why is limited to square? It can, because these are actually endless series. Okay, This can go on. The Maclaurin series, it can be go to XB cube then, since high concentration. But we have seen that up to square we can have actually reasonably correct results. And it has been reported by Darkin that if you use cube, then the results, the error that we incur considering square up to square only, not cube, that will be below experimental error. So square we can consider square is enough. Sometimes we actually delete square also. That I will tell you. Wagner's E formalism later. A square also deleted. Only dilute solution square terms negligible. But here, so it is free. You can, as if you can use for higher concentration, not necessarily dilute. So that's why I have written concentrated solution. Remember, when you measure this, it requires dilute concentration because it has to be extrapolated to zero. It should be close to zero, then its extrapolation will be correct. That's why dilute concentration. If you take a higher 40%, 50%, 60%, how will you extrapolate? There may be error. So close to dilute. So these measurements require dilute solution in this method. In this method. 4 diagrams, 4 figures I showed. Dilute. So three points each case. They're close to zero. Then you extrapolate it. And taking these 4, I have drawn the final one. Here also you may consider these are actually not very high concentration. So close. So then extrapolate to zero and take the slope of the tangent or slope of the to the curve. This is whole. So this is actually interesting. We can apply. So mind is free. This is valid. The only thing you may say, why not cube? Then the question will be, why not x to the power 4? Why not x to the like xb to the power 4, xb to the power 5? Endless. So we have to be rational. We have seen that this is, it is up to square, no problem, and can accommodate concentrated solids also. So not necessary. So this one get advantage. Okay, so this procedure this procedure suddenly, this is the over. This is over. So why we this procedure certainly what is this? Certainly reduces the current current difficulty of finding interaction coefficients for which separate experiments, four separate, and with each having 3 points or 4 points, so 16 experiments, separate experiments, and then you actually combine them into this, use those values into this curve. So then you get only one parameter. So for which separate experiments are required to be carried out are required to be carried out as I told you, with binary with binary for what? This epsilon BB for binary, and gamma B0 binary with binary, or and for this ternary for EBC ternary. This is binary. This is binary for with binary and ternary solutions. Solutions that are necessarily that 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 are necessarily dilute. So this is one great advantage we will simultaneously find 7, and we may use not necessarily dilute or more concentrated, okay, or maybe actually moderately concentrated solution also. So no problem, okay. So these after this start this point, double star, and remove this now. Remove this. This is over. For discussing second method, still this first one, these equations is needed. Okay, double star. One example is given below. In a study of in a study of removing tin from liquid iron by calcium chloride slags in an alumina crucible. Alumina in an alumina crucible at 1440 Kelvin, that is 1175 degrees Celsius. Dinabandhu Ghosh, myself, Dinabandhu Ghosh, reference metallurgical and material transaction trans D 2009. There should be volume here. Oh no, I'm sorry. Okay. Volume 40B, page 508 to 522. So this is second reference, okay. So anyway, this is the experimental part you will get, okay. But anyway, the results a summary synopsis I will give you here. Mundu goes, okay, what happens? Yes, okay. Started the solubility of started the of alumina of alumina in calcium chloride slags, in calcium slags from the measured solubility from the measured solubility of alumina of alumina at different concentrations at different concentrations of the components in the quaternary system calcium, what's the system? Calcium, alumina, since saturated because it's alumina crucible, so it is alumina saturated. Then what? Calcium chloride, tin. Calcium chloride was added, to to help remove tin, greater extent of tin. Calcium coupled with calcium chloride, and actually was treated as the slag. And alumina was also joined the slag coming from crucible. And tin also, we tried to remove tin from the metal phase to the slag phase, because tin is a deleterious, harmful element for conventional steel making. We don't want tin. We want tin for special purpose. So we want to normally remove from the scrap this tin. So anyway, calcium, alumina saturated calcium chloride, tin, representing A, B, C, D. A, B, C, D. A, B, C, D, representing A, B, C, D at what? At a certain temperature, at equilibrium. We have to give time for equilibration. 12 hours, 18 hours. Then when equilibrium was ensured, then these are the equilibrium values that we can apply here. This is equilibrium value. This is all equilibrium values. So at equilibrium, after which there is no change. When equilibrium is attained, there is no more change. So those values actually will apply here. So at 48 Kelvin, as I have mentioned already here, and by using equation 1, I have written here equation 1. I have saved this. This is a quaternary. Ours is also quaternary. So by using equation 1, 7 unknown parameters, shall I write this? See, follow here. This you just substitute. What is the B? B, again, alumina. A, calcium. C, calcium chloride. D, tin. So 7 parameters. What is this? So gamma B0, ln gamma B0 means ln what other? Alumina 0. Gamma alumina 0. Okay. Ln. Give this Ln then in the form of Ln in 0 because they are involved here. So equation they are used. So it will be on solving this will come out. Ln gamma B 0. Then what? EBB epsilon alumina self interaction coefficient of alumina. Then what? Epsilon alumina calcium chloride. Next ones. Then epsilon alumina. Oh, alumina. Then okay, what? Actually, alumina. I made a mistake here. Okay, let us complete the cell. This cell. The next ECC. A calcium chloride epsilon. Then EDD epsilon DD teen. Then take up this is a cell ternary. So ternary is what? It will be alumina effect of what? One by one. First is calcium chloride on alumina. Second, next one on alumina whose effect? Teen. And last is and epsilon calcium chloride teen. Calcium chloride teen. 7. 1, 2, 3, 4, 5, 6, 7. Okay. So this is okay. Calcium chloride. Let me check. Calcium chloride teen. Alumina calcium chloride, alumina teen. And it's fantastic. Where determined, where now I think since I've already used this, where determined simultaneously with the help of seven sets of results. 7 sets of results. Okay. Oh, sorry, I removed this equation. This equation seven times, 7 sets. Now, for certain composition of alumina, calcium chloride, and tin, get this gamma alumina. That comes from the solubility. Composition of alumina gives gamma because activity we know is 1 with respect to solid alumina as the standard state. Alumina crucible, solid alumina crucible. Then we can convert into the liquid standard state. The change of standard state I will teach you later. So this was done. So this equation I removed just now. So 7 sets why? 1 for 1 composition set, and what is the corresponding gamma? Alumina 1 set, second set, third set. Because you are carrying out with different calcium chloride. You are varying calcium chloride mixture ratio. Okay. So with this actually you will get different concentrations of tin in the slag phase that which are interested, and that is varying concentrations you are getting. So different concentration of tin, different concentration of calcium chloride, different concentration of alumina, and rest is calcium. And we found that iron was not coming to the okay. So anyway, so it's 7 sets with the help of 7 sets simultaneously underlined. Simultaneously, that is one advantage. Okay. So number of experiments will be fewer, much fewer than the previous method, first method, with the help of 7 sets of results, experimental results. Hence 7 sets of equations. That's it. With these 7 sets of equations, you can solve the 7 unknowns. Thank you very much. With this, we have closed this one. Next, I'll take up some. So let me remove this. I will now take up assignment based on solution thermodynamics. Assignment number 9. Okay. Today I will take up this. Okay. So I could not take up until I finish this part. I cover this part. I cannot. Okay. So this what I wanted to tell you here. Then I will take up assignment number 9. Then that will be followed by maybe next class, time permitting. Next class maybe alternative standard states based on Henry's law, Henry and standard state we call it. This will be very important. These are used in the steel making problem solutions. Okay? So that this is very important. This actually we'll see and change of standard state also. So these are the things. Okay. Then we'll take up other topics like free energy composition diagram, okay, and thermodynamic origin of phase diagram, etc. And time permitting phase gives phase rule also. So this is actually down the lane. So these are. So now actually I think this is over. So there is no question of returning this here because I need space. Assignment will be taken. So I am removing this. These are still under solution thermodynamics. So keep this topic on as the primary heading and this and move on. So let me write here. Sorry, assignment 9. If you follow, it will be 9. We have already finished 8. So this is based on solution thermodynamics. Thermodynamics. Problem 1. So I am writing problem on this side and I will give solution this side as I usually do. Problem 1. So first problem is a CH4 hydrogen gas mixture a CH4 hydrogen gas mixture okay hydrogen gas mixture at 1 atmosphere total pressure at 1 atmosphere total pressure total pressure total pressure in which partial pressure of hydrogen we call pH2 is 0.955 atmosphere is equilibrated with an iron carbon alloy at 1000 Kelvin. Calculate the activity of carbon with respect to graphite as standard state, solid graphite always activity relative to a standard state. Try to specify the standard state, or if it is implied, then try to understand that. Okay, with respect to solid graphite means carbon, pure solid carbon with pure solid carbon, solid graphite means pure solid graphite, pure graphite as standard state in the alloy. In the alloy, what would be the? This is the first question. Oh no, calculate. This is a calculate. What would be the value of pH2 in the gas mixture at P total is 1 atom square have to be what would be not what would have to be in order to saturate saturate in order to saturate iron with graphite at 1000 Kelvin. This is the question. Okay, the problem taken from reference. I should recognize reference, acknowledge this gas scale, second edition. Gaskell was my professor at Purdue University and also my research advisor. So Gaskell back in 1986 to 1991, 1990. So for 4 years, 4 years or plus. So second edition, page 517. So this, given this, let us solve. Draw a line here. Solution. You just follow me. Carbon. Consider this equilibrium. Carbon. Achha, have a figure. Have a picture of the situation. You have taken an iron carbon alloy, and you are passing over it what? Hydrogen CH4, and these have a carbon potential. The story is this, and this is living. Exiting. P total 1 atmosphere. Open system. Continuously passing. What happens? This has a carbon activity. And when equilibrium will be established, this carbon activity of this gas phase will be the same as this one. So initially this has a higher activity, and supposedly this is a lower activity, which is low carbon. So higher. So continue when it is passing over it. Hang on. When this gas is passing over it, high activity and low activity, so or high free energy, low free energy, same thing. High activity, low activity, so carbon will be transferred to the alloy from this gas phase, flowing and living. But it is not yet same activity as this, but just one pulse, not enough. Continuous. Gradually, carbon content Hence, activity of carbon gradually increases, and it is still flowing. When the activity here and here will be same, then it will stop. Same activity, and there is no more interaction, because same, and so it simply flows over it without doing anything here on this thing, or without changing any more the activity, because the same activity, there is no question of changing, and this is phase equilibrium. This phase carbon activity, this phase iron carbon solid phase, and the gas phase. That is the phase equilibrium. Carbon, the components, same activity in the two phases. So this is the story. The question is what? First question, calculate the activity of carbon. Okay. So activity of carbon with respect to is when you have equilibrated, what is the activity? Your answer is very easy. When equilibrated, when just equilibrated. So moving, trying to equilibrate and finally equilibrate. Then what will happen? What is the activity of carbon with respect in the alloy? You will answer the same activity as here. This is unchanged. Only same gas mixture. What is the mixture? 0.955 atmosphere hydrogen, and the balance is 0.045 atmosphere methane. They are the activity. So to get the activity of carbon here, strike equilibrium involving carbon, and that I am doing. Solution. Okay, carbon, graphite. Graphite means graphite is a standard state. Okay, these are the standard state. Plus 2 hydrogen gas. Here also standard state gas, CH4 gas, and you can get from your data. Data are supplied. If the data supplied, you write this out. Delta G0 is minus 69,120 plus 22.25 T ln and minus 65.34 T joule. This is joule per mole. Okay, this is the data given to you. Delta G, what you will get? Your temperature, partition temperature is what? 1000 Kelvin. Delta G0 1000, you calculate and you get this value 19,237 joule is, this leads to K. Your next step is equilibrium constant, K 1000. How you get this? From delta G0 is minus R3 ln K. Okay, recall this, recall. So K 1000 is what? How much it is coming as? 0.1 only. 0.1. Take this here. K 1000, 0.1 is what? What you write? Equilibrium constant expression. Partial pressure of CH4 by activity of carbon, partial pressure of hydrogen squared. This is typically at equilibrium. What is the PCH4? You are actually equilibrium. The equilibrium value here will be the same in the alloy, in the gas phase. So what is the PCH4? Write this. So this is clear. 0.955 means 0.045. Total pressure is 1. 1 minus 0.955 is 0.045. Okay. By activity of carbon, which is unknown, and hydrogen is what? 0.955 squared. If you solve this, you get activity of carbon with respect to graphite as the standard state is what? 0.49, which is very close to 0.5. So activity of carbon is 0.5. So this gas mixture has not got yet activity of carbon as 1. That is actually asked in the second part. That has been an issue in the second part. Under what condition activity of carbon will be 1? First of right answer. This is your answer to the first part. Second part you take it. So under what condition? What would be the value of it? How will you change this? you can guess when carbon activity, how can we increase the carbon activity? Tell me, you have common sense. You have to increase this. That means you have to increase methane. So if the product activity increases, the reactant activity will increase. Or to increase the reactant activity, product activity has to be increased. Or if possible, it will decrease this. So you say they actually these are binary, so you consider methane. So you increase the methane content and decrease the hydrogen content at the total pressure same. So that will be your answer. You will see that will be your answer. So you will just consider that pressure, what pressure of hydrogen, you will say P is the pressure and you will find it out. And corresponding to activity of carbon is 1. So repeat this. So repeat this for the second part. Second part is what? Again you write what is equilibrium constant? 0.1 is, you write this K1000, you write this, keep on writing, is what? You write once more, PCH4, that will help you. Activity of carbon, P hydrogen square. You write, let P be the required, what value of PHT? Required P hydrogen. So P will be your answer. Time 52. So after this I'll stop. Okay, in 8 minutes. At 2 o'clock. 52. So 8 only. Is it okay? This is okay? Then fine. So now how do you substitute this? One by one, what is the activity of carbon? Tell me. What is that? This is question is about saturate iron. Saturate iron with carbon means carbon saturated means activity of carbon is maximum. The same as the pure graphite carbon. 1. So this is the one. So what is PCH4? If it is P, what is the PCH4? 1 minus P hydrogen is the P. P hydrogen is the P means P square, and this is 1 minus P. Total pressure is 1. Total pressure is 1 atmosphere. Neutral 1. So 1 minus P square. So you can solve this. This is a quadratic equation, very easy. So what you will get, I'll help you. 0.1 P square quickly plus P minus 1 is 0, or P is minus 1 plus minus 1 root over B square minus 4AC plus 0.4, I hope. Minus 1 plus 1 plus 0.4 divided by twice A, 0.2. 0.2 is what? Minus 1 plus 1 point minus is actually absurd, plus unrealistic 1.183 by 0.2 is what? Is 0.916. This is P. That is hence required pH2 is 0.916 atmosphere. So you see, as we expected, we have to increase this methane content. Now 0.9. Now this is major component. Hydrogen is how much? Barely 0.1. So it has been used. So methane you have increased. So increase the activity of carbon to the extent that it has been elevated to 1 value of 1. It has been increased to 1. It has been. Answer this problem is over. Second problem. Second problem is over. Okay. Second problem. Problem 2. Remove this. Problem 2. Consider problem 2. I already told you actually that's this okay, this reference I gave you is from Gaskell, first one I already gave you. So I think calculate this also from Gaskell. Calculate the activity of FeO in an FeO Al2O3 SiO2 melt below which the FeO cannot be reduced to pure iron pure liquid iron by a CO2 mixture of PCO over PCO2 by PCO2 is 10 power 5 at 1600 degree centigrade. 1600 degree centigrade is typical steel making temperature. Okay, we will have many problems at 1600 degree centigrade. We will have many problems. Okay, which involves 1600 degree centigrade. So this is a problem taken from Gaskell. Reference Gaskell. These are actually exercise problem. Exercise. So reference Gaskell, second edition, page 517. Quickly, this is a problem. Answer, solution. Quickly. The pertinent equilibrium is what you try to see. Pertinent equilibrium is, you write this: FeO liquid plus CO gas is Fe liquid plus CO2 gas. Quickly, and delta G0, you will get the data. Delta G0 of CO2 minus delta G0 of FeO liquid minus delta G0 of CO. Recall this. So I am giving you the data: minus 394 minus 0.84 T. This is CO2. Then minus FeO liquid and others. Minus what is this? 232,702 plus 45.312 T, and minus still another minus, that is of CO. What is minus 111,700 plus 87.65 T. Minus 87 point minus 8 plus, it is minus the hertz completed 5-6 minutes. Minus 87.65 T. Okay, it will be around. It will be over soon. It is minus 49,700. In 5 minutes it will be over. Hello? 41.5 T joule. Okay, or this is the data first of all, or delta G0 1873 is what at the temperature is if you do this okay, is what 280 T 29.5 joule, or K 1873 is from delta G0 is minus RT ln K again, recall. K 1873 will be 0.165. You just follow this. Is what? What is this expression, right? Activity of Fe liquid. Activity of Fe liquid. You write that. Fe liquid, write this PCO2 by activity of FeO liquid. PCO. Now of this, what are at equilibrium? Of which is given, which is has been equilibrated. What is the pressure? This is the 10 to the 5 CO by CO2. So CO2 by CO will be times 10 to the minus 5. Activity Fe is what? What? It is what? It is what? 2 pure liquid iron. So it should produce pure 1. So 1. Activity of FeO is the unknown. Unknown. Or you find the activity of FeO, which comes out to be as 6.05 times 10 to the minus 5. This is because this is impure. This is present where? In alumina silica. With alumina silica, FeO alumina silica. But you will consider this equilibrium to find the activity of FeO that is present in this. Okay. So you can write any equilibrium, and this is the pertinent equilibrium. So very good, very good, very good. 6.05. So what is the answer? So below this FeO, below this activity FeO. So this is the equilibrium. Follow this. Follow this. This is the equilibrium with this pressure. Equilibrium with this. If you, so that means this is equilibrium. Means it can, this CO2 cannot reduce this. And below this, if it is below, it cannot reduce further. Okay. So what happens? So below which, below this value, if FeO is less than this, is less. If it is less than this, if it is less than this, what happened? With the same CO2, Fe liquid will be, if this is less than this, if this is this, then it is 1. If this is less than this, iron liquid will be less than 1, means it will not be produced pure. When produced pure, 1. When it will be less than 1, then it is not produced. Follow again. So it will be, if it is to be produced, it must be produced pure. So there is no metal phase. There is no manganese, silicon, etc. Again, corresponding to this activity, this is the 1. If this is below less than this will be less than 1. Means it will not be produced pure. Not be produced. So below activity, this activity FeO, FeO cannot be reduced by the given CO2 mixture. Okay, with these words, we have finished today's. There are I would say there are, okay, over. There are, I tell you what, there are 7 problems. 2 already over, 5 I will take up in the next class. And then time permitting, I will go to the alternative standard states. This is my plan. This is the program. Okay. Thank you very much for your attention and for your cooperation. Thank you. See you next class. Bye.